title page. So the object of this, or the objective of this lesson, is to learn how to do function inverses. All right. So a function has, now here's the thing, is that not all functions have inverses. Well, I shouldn't say that. All functions have inverses, but not all functions have inverses that are functions. And that's an important note to make. If you remember, to become a function, it has to pass what's called the vertical line test. So if you see here, you have this function. It's a quadratic, okay, x squared. That passes a vertical line test, right? If you were to draw a vertical line up and down anywhere on that function, you would only hit 1 point. But the inverse of that function is this piece right here. You see that? Okay. This would not pass a vertical line test. If I draw a vertical line test here, I'm going to hit 2 points, okay? So a quadratic function inverse is not a function, okay? Now, when you're graphing functions, you'll notice, and this is something the book asks you to do a little bit of. I'm not really that fussed about graphing or being able to graph them, but you should be able to recognize them. So to graph an inverse, so you have a function, you use this line here, this y equals x line, and you reflect over it. So if you reflect over it, that's the graph of your inverse function. So that's just kind of the first vocabulary here. A one-to-one function is a function that actually has its inverse as a function. So we're going to talk about how to tell if functions are one-to-one or not. I'm going to move this to full screen. So let's go ahead and continue. Let's look at an example of functions. So the first example asks you to find the inverse of a function. Now, this is, we can do this algebraically, which is really nice, because graphically it's very difficult. So to find an inverse. Now, this is an interesting one, that the inverse actually ends up being the function itself. This does not happen very often. But here's the rules, okay? And this is super easy to do. If you listen carefully, you can do this to any function, all right? So I start with a function, and I'm actually going to change the, instead of f of x, I'm going to change it to y, okay? So this is now y equals x minus negative x. To find the inverse, I have to reverse the x's and y's. So wherever I see a y, I'm going to put an x, and wherever I see an x, I'm going to put a y. So I invert them, and now I have x equals negative y. Now to find the actual function, I have to solve for y. Sometimes this is super easy to do, and sometimes it's complicated. When it's inside parentheses and you've got to get it out, and you're doing square roots and all kinds of stuff. This is a fairly easy one. I want y alone. The only thing I have here is a negative. I divide both sides by negative 1, and I get y equals negative x. So this function and its inverse are the exact same equations. This does not happen very often, and I probably picked a crappy example to start with. But these are the exact same equations. Again, does not happen. Usually it will have a different equation. So try the practice problem. It is a little more complicated, but not terrible. So you're going to make it y equals 3x minus 2. Where you see x's, put a y. Where you see a y, put an x, and solve for y. Okay, and here's your solution. All right, next example. So we want to determine if this function is one-to-one, and we talked about this a little bit in conceptual, where if it's one-to-one, it means that it will pass what we call the horizontal line test, because if it's one-to-one, then if we invert it, it will still pass, then it would pass the vertical line test. So what you have to do is graph this, first of all. Now this function, I have this all graphed already, and it's all pretty, sort of. I don't draw well. So this is the little red line. This is my function, okay? And you notice if I draw a vertical line anywhere on that, I do actually end up, it's a function, okay? It passes the vertical line test. But if I draw a horizontal line, almost anywhere in the function, I'm going to hit more than 1 point. In fact, right here, if I were to draw a vertical line right here, I would hit 4 points. Okay? Because it doesn't pass the horizontal line test, it is not one-to-one. That means that its inverse is not a function. Okay, try this one on your own. Graphing calculators, that's what I was going to tell you on the last one. Put it in your graphing calculator, see what your picture looks like. Okay? If you can't see it, change your window. Here's your solution. And it does actually show how to create the inverse of that, but you don't have to do that part. All right, example 3. Okay, so another way that we can tell if functions are actually, inverses of each other. So instead of, you could take the function Like we could take either f of x or g of x and solve it by putting y there and inverting it like we did before. Or we can use composite functions to determine if they are actually inverses. If you use composite functions, your goal is to get a single x. When you get a single x, you know that you have succeeded. If you don't, they're not inverses. So what I'm going to do is I'm going to make composite. I'm going to do f of g of x first and see if I end up with x. So when I plug g of x into f of x, I plug x minus 1 into this x here, and I get x minus 1 plus 1, and I end up with x, because a negative 1 plus 1 is 0. So I know that if I go this direction, I'm pretty close to having an inverse, but I have to check the other direction too. Now I do g of f of x, so I'm going to plug this f of x function in to the x here. My x plus 1 minus 1. 1 minus 1 is 0, so I do end up with x. So this is how we show that two functions are inverses of one another. All right? Now, here's one, again, it's much more complicated than the example because it has fractions, but you can still do it, okay? Go ahead and plug them in to each other and just solve it out. See what you get. Hopefully you'll get an x, and then you can say they're inverses. All right. So this is the solution. Obviously, they did a lot of steps with fractions and that kind of stuff, so all right, and that's it. See you tomorrow.